Alright guys, this is Algebra 2, Chapter 5, Section 1.3. So we're going to be talking about inverses still. So to start off, pull that up, here we go. So I'm going to look at this table here on the right. So if I wanted to get a inverse of this table, I would literally take the x and y variables and I would transpose those, right? So now my x column is my y column and my y column is my x column, right? And then I would have my inverse table. If I wanted to get the equation of the inverse, like we've done in the past, we take the x value and the y value, we transpose them just like we did on that table. And then as soon as we do that, we have the inverse. But I typically want to have it so it's solved for y. So get that y by itself, and then I have an equation in a form that's a little bit more friendly and useful for me. So we've gone over that process quite a bit in the past, so I'm not going to dwell on it here on problem 40, but I want you to try it out on problem number 41. So go ahead, pause the video, and then for 41, transpose the x and y, then solve for like y, and see what what equation you get there. That should be your inverse. So go ahead and do that, and then I'll come back here and we'll check them. All right, so here is the answer key for that. Let me pull that up over here. So we should get this for A, B, C, and D. D can be the one that's a little bit more tricky there just because there's so many little small parts to it. And that one, if I can kind of see here. So we're going to have to get rid of the 6 first. So we're going to subtract over the 6. Then to deal with that 4/3, again, we're going to be dividing off that fraction there. So when we divide by a fraction, we're going to be multiplying by the reciprocal of that fraction. So hence the 3/4 here. And then we're going to be wanting to get rid of that third power. So that's a third root right there. And then lastly, to get rid of that -1, we're going to add the 1 on the outside there. And then we have it by itself. So that's effectively our process there. So these can oftentimes look kind of ugly. That's just because when we do things in this kind of inverse order, we end up having a lot of parentheses and things. If I can simplify a lot of this stuff down, but there's really not a big point to right now. It's actually going to be a little bit easier for us if we don't, once we kind of get to this very next step. So what I want you to do is go ahead and pick one of those pairs, either A, B, C, or D, and the B pair being your original, and then the inverse we just found. So like, here's the original, here's the inverse. So pick one of those pairs. We're going to call the original f of x and the inverse g of x. So then we're going to be moving on here to the next one. So get this over here, and we'll take a look. So 42, here's another way to kind of look at how these inverses work. So we're going to be taking an input, we plug it into the f, it does its job, and then it gives us an output. We take that output, we plug it into g, which in this case is the inverse of f, and then it does its job, and then we get the output. And that output should be the exact same thing we put in at the very start. That's what inverses do. G being the inverse of f means that it'll undo literally everything f just did, right? So with the two functions you just took, right, we have the original named f, the inverse named g. Take 3, plug 3 into f, see what you get. Your output, take that, plug it into g, see what you get as your output. It should be 3. So go ahead and pause, try that out, and see what happens for us. Okay, so what we can do now is saying, well, can we write that in a different way, right? So how we could write that is when I plug 3 into f, we call that f of 3, right? That's just our notation for saying, hey, I'm plugging in this value for all of the x's. Well, then once I did that, my output is also called f of 3. Now it has some number, but if I'm just being really general, it's f of 3 is the output of 3 being plugged into f. So f of 3, I'm then plugging that into g. So I can look at it like this. Well, f of 3 is being plugged into g. And what I got as my output there was 3. So that's effectively what this is saying. So this is just a really kind of algebraic way of showing what this function machine is doing. I plugged in 3 in f, hence the f of 3. Then I plugged that into g, so the g of f of 3. And then my final answer, my output total, was 3. So that's what it says. Now on D, we're asked, well, what if we did f of g of 3? Is that the exact same thing, right? Does it matter if I do G or F in that order? And it does, right? You cannot just transpose the order. I cannot just put G on top of F and get the same result out of it. Now, Now, in special cases, you can, right? And those are cases where they are inverses. So on this one, you will get the same result out of it, but they are not the same thing for forever and always. So that's not a rule you ever want to try and follow. It's an extremely specific case when you get the same result either way. That is, again, for these inverses. So last thing that we can do here is try and do what's called the general case, right? So we're going to take the general case, meaning I'm going to be plugging in x as opposed to plugging in 3. Because I could, just keep on plugging in numbers. I plugged in 3, I could plug in 7, I could plug in 12, I could plug in -8, plug in any number, and I could just test all of them and see if does everything work. But that would be forever because I have an infinite number of values to plug in and check. So what I'm going to do instead is the general case. Meaning, well, I'm going to let x represent every number, right, or any number that I could ever want. And if I plug in x and I get out x, that means any number I plug in gives me its same thing back out of it. So let's try that out, right? So we're going to try to see, does the g of f of x give me x as my result? So let me go ahead, pull out my document camera, and we'll try this out. So what I want you to do is, first, on yours, pause, try and plug in x for your f, get that result, plug that into g, and then it should simplify out and you should get x. Once you're done, go ahead and come back here and I'll do one of those so that you can see it if you're having a hard time. Okay, so we're going to change over to my document camera. Get that to zoom effectively. It looks pretty good. Okay, so the function that I need, I'm going to actually go back here so I can see the functions. All right, so we got, I'll do the first one just because it's first. My original, my f of x, was 2 times x minus 1 cubed, and then my g of x was the third root of x over 2 plus 1. Okay, so what I want to do here, tilt that so it's a little bit more straight for you, all right, is I'm plugging in my f into my g. So my g of f of x would be the third root of all this is in for that x, so that's 2 times x minus 1 cubed over 2. Went a little bit long there. And then I had the plus 1. So again, I'll circle that or highlight it so you can kind of see that all of this is what got plugged in for the x. So I just plugged in whatever my f was in for that x, and that's what I ended up getting out of it, right? So now, well, let's try and simplify it out. Well, 2 and 2, those are going to cancel, so I got the third root of x minus 1 cubed plus 1. Well, the third root of a cube is going to be canceling out again, so that's just x minus 1 plus 1. Well, minus 1 plus 1 is 0, so that's just x. And there we go. Meaning, if I plug in x, so I plug in x here, I get out x. So that works for everything. So that's me. That tells me, hey, I've got myself an inverse here. Now that should happen for any one of those pairs you will get. So hopefully we are seeing that happen. All right. All right. So then back here for 44. If you talk about the intercepts in the domain and the range, what you'll find is, if you think about, again, that the inverses is just the x's and y's being transposed, right? So if I have an x-intercept, that becomes a y-intercept in my inverse. Likewise, if I have a y-intercept, that becomes an x-intercept in my inverse. My domain is just all my possible x's. So in the inverse, it becomes all my possible y's. Likewise, my range on my A originals, if I take the inverse, it just becomes all my possible x's, or my domain. So your domain becomes your range becomes your domain, your x-intercepts become your y-intercepts, and your y-intercepts become your x-intercepts. So to round off here, what we just did is what's called composition of functions. Now, how we wrote it is how you're going to see it for most of the time, just like f of g of x or g of f of x, stuff like that. You will occasionally, especially in much older text, see it written like this. This is a notation that's kind of dying out, so it's not nearly as common now as it was years ago. But I still want you to be aware of it, just in case you do see it in a future class in college or something like that. Right, and then lastly, are 3 ways of finding an inverse table. Really easy. Take the x and y column, we transpose those. Graph, we want to reflect it over the line y is equal to x. And then lastly, with any equation like we did multiple times today, transpose the x and y and then solve for that y. There we go. All right, with that, here is our homework for 513, and I will talk to you guys next time.